Okay, reminders. Let me make this bigger. Your D2L quiz number 6 is due today. Your handwritten quiz number 5 in grade scope is due today. Yeah, I should take that in there. A midterm review homework assignment in Infinity is due Wednesday. And then we'll have no class Wednesday or Friday. Wednesday, you have to take your midterm. One part is done during class time. One part can be done anytime Wednesday, whenever you wish. The handwritten part is in grade scope. It's only open from 12:30 to 3, and you have a 1-hour time limit. That means if you don't start it until 1:45, you only get 15 minutes, right? Like it closes at 2. This says 2, not 3. It's only open from 12:30 to 2 during class. It closes at 2. If you don't start it till 1:45, you're only getting 15 minutes, okay? So it's just like the quizzes. Once you open it, you print it out, write your work, upload, and then just like your handwritten quizzes have been all along. The Infinity portion is open all day Wednesday. So 12:01 a.m. Wednesday morning until 11:59 p.m. Wednesday night. But it is a time limit. So it's not like a regular Infinity assignment. You can't do them over and over again. You get one submission. Once you start it, you have your 1-hour time limit. Yes, ma'am.
So do you think that we could, I know there's only partial credit for that thing, but like, do you think that you could maybe open a Dropbox for like our work and we can put it that way? Because sometimes I feel like the way that you put it into Affinity, like it might be the right numbers and everything, but the way like maybe you forget brackets or something.
Yeah, so I will after the thing is over, once it grades it on Thursday, if you send me, if you think that one of them marked you wrong because you didn't put a parentheses where you needed or something, then you can just shoot me an email and send me a picture of that, your work for that question. And I will think about it. Yeah, I'll see what I can do. And then Friday, no class. It's midterm week. We're taking Friday off. My sister's getting married. I'm flying to New York for a wedding on a farm. It's gonna be great. It's gonna be great. Perfect. What'd you say?
I said have fun with that.
Yeah, it's gonna be great. My kids are all like, how many classes do I have to miss? I'm like, calm down. Right? I mean, they're not that excited. We're flying Friday and coming home Sunday. So it's like whirlwind trip. We did get a direct flight though, so that's nice.
We're in New York. I have a lot of family.
So now my parents live near Albany, New York, in Rotterdam, it's called. That's not, I grew up in New York, but not there. I grew up at the very top northern tip of New York on the St. Lawrence River, Canadian border, in a town called Ogdensburg.
Okay.
Yeah. I went to school up there in a town called Potsdam.
Okay, so you're north of even Syracuse.
Yeah, if you go to Syracuse and you go as far north as you can on that interstate, then you run into the town I was in.
Yeah, because I think I have a friend up in Watertown. Is that nearby?
Yeah, that's one more hour north.
Okay.
Keep going one more hour north and then you'll get there.
Yeah, that's
Yeah.
that's right.
When you say New York, people think oh, you're from the city. No,
No,
it's 7 hours to New York City from my house.
Yeah, when my grandparents lived in New York, but and some people would think my grandpa was from the city, but he's actually from Queensborough.
Yeah, no, I'm as country as you can get in New York. Yeah, think about the countryside of New York. That's me. Okay, so today is just a review day. There's no more questions about the midterm, right? Everybody knows what you have to do. You're confident you're going to do well. If you do that review assignment on Infinity, you are going to be well prepared.
Are we allowed to use our notes?
Absolutely. Yep, you can use your notes. Sure. Yeah, you're at home. Whatever you do for a regular grade school quiz, you can use your same. Okay, so I'm ready for questions. 7. Yeah, today's just a question day. 7. I gotta get that stupid snipper out. Just a minute, I'm not ready. Yeah. 11, 16. 15. Wait, I'm not ready. 7, 11, 15, 16. Did somebody say 14? 18.
I think
Someone said 14. Did somebody say 14? You guys.
this point.
7, 11, 14, 15, 16, 18,
23.
23,
22.
24, 20. What'd you guys say? You were just shouting random numbers. Fine. Snipping Tool is moving. In a future update, Snipping Tool will be moving to a new home. Try features and with snip like usual with snip and sketch. 17.
I think that little pop-up, it's like, here, why don't you open it? It's like, okay, you
Right.
open it, but it doesn't close that pop-up. So the moment you hit the record button, or like, so you take, so you want to take the sketch, it's like, oh, but this pop-up you gave me is still in the way, so you can't actually do that.
I don't like Windows. That's all I'm saying. Okay, that's probably enough
Glad you
pages.
gave me this little warning here.
Exactly. Now you can do what you want. No, you can't. Okay, 7. 11. Fourteen. Oh, it's in the wrong spot. 15, 16, 17. Okay. Fifteen. 16. 17. No, can't do it that way. Okay, how am I doing? 18, 20, 23, and 24. Oh, 18 is a lot of words. I think we've done that one before. Almost done. 23. 24. All right, here we go. I am starting with 7. 7 says evaluate the following limits. If the limit does not exist, enter DNE. If the limit is positive or negative infinity, use the palette to enter the symbol. So this one says limit as x goes to infinity of this function. So we're taking limits at infinity and negative infinity. What are we looking for about the graph? Yeah, the like end behavior, the horizontal asymptote, the right, what happens, does it level off or not? We can do that with the graph, or we can do that by like distributing and finding the degrees of the numerator and denominator. This piece on the top and the bottom looks, these two questions are the same, right? It's the same function in both questions. One's going towards infinity, the other's going towards negative infinity. So I'm going to distribute, but I only care about the highest powers of x, right? I don't care about anything else when I'm doing end behavior or horizontal asymptotes. So I'm only going to do the negative x times the 9x and the negative 11x times the 2x, because everybody else is that's gonna be degree 2, and everybody else is gonna be smaller than that. Agreed? Like if I FOILed that all out, I would get like an x squared term, an x term, and a number term. But I only care about the x squared terms. So I'm gonna multiply the negative x and the 9x and the negative 11x and the 2x. So I get negative 9x squared on the top plus some other stuff, which I don't care about. And I get negative 22x squared on the bottom plus some other stuff, which I don't care about. I may or may not have started the recording. I did, good. Okay, so the horizontal asymptote, because these two degrees are the same, there's a horizontal asymptote at the coefficients, right? At 9/22. So in this case, I'm gonna get 9/22 for both of these limits. There's a horizontal asymptote at y equals 9/22. The only time you're gonna get different end behaviors at infinity and negative infinity is if you have like exponentials or logs in there. If you have just like nice polynomials, rational functions, then your end behavior is gonna be the same on both sides. It could be both rising and falling, or it could be leveling all at a horizontal asymptote. Yeah.
All right.
So you look for the degree term and you take the coefficients. If the denominator is bigger than the numerator, it's going to be at y equals 0. And if the numerator is bigger, there's not going to be one. It's going to like rise or fall on the ends. If you had graphed this function, you would have seen there was a horizontal asymptote. It would probably be hard to find what its value was, but you would have seen that you were looking for a horizontal asymptote. Okay, 11. The population of a slowly growing bacteria colony after T hours is given by this function. Find the growth rate after 3 hours. Yeah, the derivative tells you the rate at which things change, right? So if you want the growth rate, you're going to find the derivative and you're going to plug in 3. So let's find the derivative of this function. 6t plus 35. Plug in 3. 6 times 3 plus 35. 53. 53 bacteria per hour. At 3 hours, right? At 5 hours, the growth rate is going to be different. At 1 hour, the growth rate is going to be different, right? But at 3 hours. No, I will not make you use the definition of the derivative again. I might make you understand what it means, but I'm not going to make you use it again. So like, you remember on the homeworks before, we did the questions that were like, here's this limit, it relates to a derivative, what would the pieces be? I don't know if you remember those. If you don't, go back to that homework number 3 called the derivative. And there were questions like that on there. But I won't ask you to compute something only using the definition. Now that you know the derivative rules, you are free to always use them from here on out. Okay, 14. Find the derivative of this guy. I think this guy says cotangent x over 9 plus cosecant x. Hey, what rule do you need to find the derivative of this guy? The quotient rule. Yeah, the quotient rule. Quotient rule says bottom 9 plus cosecant x times the derivative of the top. What's the derivative of cotangent? So close. Negative cosecant squared. Negative cosecant squared. Okay, minus top cotangent of x times the derivative of the bottom. Now we need the derivative of cosecant. Negative, I think it's negative. Yeah. Cosecant, cotangent. If you have that sheet, you can just look that up on that sheet. Divided by 9 plus cosecant x squared. Yeah, the bottom function squared. So this is the product rule, g f prime minus f g prime over g squared, where this guy's f and that guy is g. When you're entering the sines and cosines and trig functions in infinity, it needs these parentheses around your x.
So the first one up top is the quotient rule, and then when you just wrote is the product rule.
No. This is the original function that we started with, and this is its derivative using the quotient rule.
Ah.
I have a question. So the addition the question is like it's right or not? No? In the exam.
It's right or not?
you know,
Yeah, it's, you just submit what you have. Yeah, just be careful with your parentheses and stuff. I think it's better to use more parentheses than less.
They're gonna create it immediately, like, so as we submit it, it's created.
I think so. I don't know if it will release the grade to you after it ends or right after you submit it. I can't remember that setting. They have like a test mode and I can't remember what that setting says. But it will grade it automatically. But it will. Yeah. You'll know your grade on the midterm by Thursday. Because that I'll grade grades for like Wednesday afternoon, Wednesday night. It looks funny when you look in D2L for your grade because it's going to have to put 2 grades in there, one for your grade scope score, one for your Edfinity score. Then I have to add them up by hand. So when it says midterm total, that's the score you're looking at. Okay, 15. 15 says find the equation of the tangent line to this curve at the point 0, 5. The equation of the tangent line to this curve. How do you find the slope of the tangent line? Take the derivative. So I have to take the derivative of this guy. Which rule do I need to use to take the derivative of this guy? The quotient rule. Okay, so bottom sine x plus cosine x times the derivative of the top. 0. Yeah, minus top 5 times the derivative of the bottom. Derivative of sine x is cosine x minus sine x all over the bottom function squared. Okay, I'm trying to find the equation of the tangent line, so I need to find the slope. To find the slope, I'm going to plug in this point that they gave me, 0, 5. This is 0 here, so ignore that term, right? So -5 times cosine of 0 minus sine of 0 over sine of 0 plus cosine of 0 squared. Cosine of 0 is 1. Sine of 0 is this guy's 0 also. That guy's 0. There's a lot of zeros there. -5.
Can you know that, like, sine to the -1 power and then just solve it through that?
Chain rule instead.
Yeah.
That's fine too, yeah. Okay, so that's the slope, right? I need the equation of the line. How do I get the equation of the line? Point slope formula. Yeah, so my slope is -5 and my point was 0, 5. So my equation of the line is going to be y minus 5 is m, -5 times x minus 0. Y minus 5 is -5x, -5x plus 5. Someone fell down there. That's the only choice. Or they're doing somersaults. My 10-year-old does somersaults everywhere he goes. Onto the couch, off of the couch, into the living room, out of the living room, everywhere he goes.
Off of the couch.
Somersault. Off of the couch, yeah. He's 10 though. I think they're like made of rubber or something. And he's like this big around. Okay, if f of x equals, I'm sorry, this is number 16. If f of x equals x cubed plus 3e to the x, find f prime of 4, and then find the equation of the tangent line at x equals 4. Okay, so I got to find f prime of 4. Let's find f prime of x. Derivative of x cubed, 3x squared, plus derivative of 3e to the x, 3e to the x. Okay, I'm going to plug in 4. 3 times 4 squared plus 3e to the 4. 48 plus 3e to the 4. This is my slope. How do I get my y value? Plug your x into the original equation. Yeah, so I'm going to get my y value. If x is 4, then y is f of 4. Oops. 4 cubed plus 3e to the 4th is 64 plus 3e to the 4th. Okay, so I know my slope is 48 plus 3e to the 4th, and my point is 4 comma 64 plus 3e to the 4th. So my equation looks like y minus y1, 64 plus 3e to the 4th, equals m, 48 plus 3e to the 4th, times x minus 4. Okay. Y minus 64 plus 3e to the 4th. I'm going to distribute that slope, so send this guy through. Equals 48 plus 3e to the 4th x minus 4 times 48 plus 3e to the 4th. To solve for y, I have to add this guy to the other side. 48 plus 3e to the 4th x minus 4 times 48 plus 3e to the 4th plus 64 plus 3e to the 4th. So this is my slope, m, and this whole other piece is my y-intercept. Like this whole thing here is my y-intercept. So if I'm just entering this in, I'm going to put this guy in for m and that pink guy in for b. You can put that in your calculator if you wanted to, but if you put it in like that for infinity, it should check it. I think if you put it in your calculator and get some decimals, as long as you keep enough decimals, it should mark it right. So keep more than less. 4 maybe. I don't know how many. 2 and it works. Okay, from the table below, calculate the quantities. Okay, f minus g, f times g prime. Oh, look, this guy doesn't have a prime on him. You see that? This guy right here, he doesn't have a prime on him. Let's do him first. He doesn't have a prime, so to do f times g of 1, we're just going to do f of 1 times g of 1. So we're going to look in our table. F of 1 is 2, and g of 1 is 3. So this is 2 times 3, or 6. That one was an easy one. How do you do f minus g prime? F prime minus g prime. Yeah. So I'm going to look in my table. Here's -2. F prime is 32. G prime is 21. So 32 minus 21, 11. How do you do f plus g prime? This one down here. F prime plus g prime. Okay, we already looked these guys up. 32 plus 21, 53. Okay, so this guy's the hard one. How do you do f times g prime? Product rule. Yeah, great. I mean, it's not hard. F g prime of 2 is product rule. F prime times g plus f times g prime. Is it 2 or -2? It's -2. Squeeze that negative in there. Okay, so I have to look at my table. I need f prime of -2. I need g of -2. I need f of -2, and I need g prime of -2. So I need this whole column. F is -22. G is -15. So F is -22. G is -15. F prime is 32 and G prime is 21. F prime is 32 and G prime is 21. And then you put that in your calculator. I don't have my calculator, so I'm not putting it in. You can do it though, I think. We've seen a lot of this kind of problem, right? Where you have a table. The thing about this kind of problem is that it's harder for you to like use Wolfram Alpha or photo math or something, so. Probably, hint, hint, hint. You might see that kind. Okay, is this the one with all the words? You better practice them. The position of a body moving on a coordinate line is given by this thing. Find the body's displacement and average velocity. Find the body's velocity, find the body's acceleration. Oh, how do you find velocity and acceleration if you have position? Velocity is the first derivative. Acceleration is the what? Is the second derivative. Okay, so for these two questions, I'm going to take the first derivative. I'm going to plug in my numbers 0 and 6. I'm going to take the second derivative. I'm going to plug in my numbers 0s and 6, right? How do you find average velocity? It's just the slope. Average velocity is just the slope. So average velocity, you're going to do change in y, s of 6 minus s of 0, over change in x, 6 minus 0. How do you find displacement? Yeah, final minus initial, s of 6 minus s of 0. Because remember, displacement is different than total distance traveled. Displacement is I start somewhere, you close your eyes, I do something, you open your eyes and you see how far I went, right? I could have gone nowhere, but I could have walked a whole bunch, right? Whereas total distance traveled is how many steps my watch told me I took. So displacement is just where were they at the end? Where were they at the beginning? How far did they move? Average velocity is the slope, the secant line, and then velocity. Okay, do you want me to do them? I don't know who asked this question. You're okay now? Okay. Okay, let's look at part D. Part D says, when, if ever, during the interval, does the body change direction? Oh, that's a good one. Let's do that one. When does the body change direction? If the body changes direction, what happens to the, what changes if you change direction? The velocity goes from the slope, yeah, it goes from positive to negative, right? But if I'm walking forward, my velocity is positive. If I'm walking backward, my velocity is negative. If I change direction, the velocity goes from positive to negative. So if I want to find out when, if ever, I change direction, what should I look at? The velocity. How do you find the velocity? First derivative. Okay, so first derivative is t squared, no, 2t minus 4. 2t minus 4. 2t minus 4 is 0 when t is 2. Okay, it's 0 here at 2, yeah? Before 2, is it a positive velocity or a negative velocity? Like at 1, is it a positive velocity or a negative velocity? Negative, because 2 times 1 is 2, minus 4 is negative 2, right? At between 2 and 6, like at 3 or 5, is it a positive velocity or a negative velocity? Positive. So it changes direction at t equals 2, but not again, right? Because this was the only place it was 0. It can't change direction if it doesn't stop first. So I took the velocity, I set it equal to 0. I checked either side to make sure it actually changed direction. It could be that they were walking along, they stopped, and they just kept walking forward, right? Like maybe there was a stop sign or something. But in this case, they were walking along and then they went backwards. They forgot their umbrella in the car. All right, here we go. 20. Oh man. Okay. This guy says square root. I'm not going to write it as square root though. E to the x to the 5th cosine x. What power should I put here? 1/2. I need a bunch of chain rules. I sort of have 3 layers to this question. 4 layers? I have 4 layers to this question. I have the most outside layer, the 1/2. Then I have this layer, the sine. Then I have this layer, the e, right? And then I've got this stuff left, the x to the 5th cosine of x. I need the product rule for that stuff, the x to the 5th cosine x, right? So the outsidemost layer is the 1/2. And then I have the sine, and then I have the e, and then I'm gonna need to do the product rule to take the derivative of that insidemost piece, x to the 5th cosine x. Okay, so the outsidemost layer is the 1/2. Bring the 1/2 in front, leave everybody inside the same to the negative 1/2. So sine e to the x to the 5th cosine x times. Okay, I did the 1/2, so now I'm doing the sine. Derivative of sine, cosine e to the x to the 5th cosine x times. I did the 1/2, I did the cosine, now I'm doing the e. Derivative of e to something? E to something. Times. The last piece I have to do is the x to the 5th cosine x. To do the derivative of the x to the 5th cosine x, I need the product rule. Derivative of the first, 5x to the 4th, leave the second alone, plus first times the derivative of the second, negative sine x. I want you to be careful that this term right here is always an exponent. So look here, it's an exponent, it's an exponent, it's an exponent. The 5 is also an exponent, but the cosine is not, right? So just be really careful if you're typing that in infinity, where the exponents go and where the exponents don't go. So the pink stuff should all be in the exponent of the e. The 5 should be the exponent of the x, but the cosine should be on the same level as the x. Okay, that was a good one. 23. Suppose, I'm sorry. You're done with that one? You're done? And that's it. Suppose, I only have 2 more left, I think, right? Unless we add more to the list. I got time. Suppose that f of x is 4x plus 5 to the 1/4. Find the equation of the tangent line at x equals 2. All right, how do I find the equation of the tangent line? Derivative. Okay, chain rule. F prime of x is bring the power in front, leave everybody in the inside alone to the negative 3/4. Good. Times derivative of the inside is 4. Okay, I'm looking for it at x equals 2. So I'm going to plug 2 into this derivative, and that's going to give me my slope. 1/4 times 4 times 2 plus 5 to the negative 3/4 times 4. That sucks. 8 and 5 is 13. Some number. You have to do a decimal. It's not a nice number. You can ignore the 4s though, right? Because there's a 1/4 in the front and a 4 at the end, so they cancel out. So make this some decimal. Keep like, how many decimals do I need? Does anybody know? 2, 3, I don't know. Keep 3, just for safety. 0.146. Anybody else? Yes, we have confirmation, 0.146. Okay, this is the slope. I know that x is 2. How do I get the y value? Plug in 2, okay? So 4 times 2 plus 5 to the 1/4. Okay, somebody put that in their calculator too. $1.90. Yeah. Anybody else? Yeah. Okay. So my slope is 0.146. My point is 2, 1.90. I'm going to find the equation of the line. Y minus 1.90 is m times x minus 2. Okay, distribute. Wait, what's happening? Oh my God. I'm trying to like do math and write at the same time. Okay, 0.146 times 2 is 0.292. Okay, and I'm going to add 1.9 to both sides. Plus 1.608. No, did I get it right? I don't know. You were clapping. Is it right? Yes, okay. Equation of the tangent line. That was the easy part though, because the second question says, find all the values of x where the tangent line is horizontal. If the tangent line is horizontal, what's the slope? 0. Which thing on this page tells me the slope? The derivative. This guy right here tells me the slope. I want to know where this guy is 0. Set it equal to 0. Okay. Yeah. 4x plus 5 to the negative 3/4 equals 0. This is like 1 over 4x plus 5 to the 3/4, right? Can a fraction equal 0 if there's only a 1 in the numerator? When does a fraction equal 0? When the numerator is 0, right? A fraction equals 0 when the numerator is equal 0. This guy can never be 0. Can't happen. I don't know what it tells you to put in there. Enter none. None. If we graph this function, 4x plus 5 to the 1/4, he's never going to be 0. Let's graph him. It's never going to be horizontal. Y equals 4x plus 5 to the 1/4. You see, he's vertical here at the beginning, but he's never horizontal. He just kind of gets like smaller, smaller, smaller. He doesn't even have a horizontal asymptote, right? He goes up forever, just really slowly. So he's never going to have a slope of 0. He looks like he has an undefined slope here at negative 1.25. Like right at the beginning, he has an undefined vertical slope, but he never has a horizontal slope like that. What'd you say? I don't know. I don't think so. That's the derivative. The derivative was negative 3/4. Yeah.
Could you graph either one?
Yeah, you could graph either one. Do you want to graph the other one? The derivative was, you want me to do it before I simplified? 1/4, 4x plus 5 to the negative 3/4 times 4. You see how he never crosses the x-axis? He gets really, really close to the x-axis, but he never touches him. There's like a horizontal asymptote on the x-axis for this guy, but he never touches the x-axis, so he's never 0. But he's vertical here, like really big, right? All right, what do we got? 24. Oh, another table question. There you go. Okay. Oh, we did this one. Let's do them again. Find h prime of 1 if h of x is f of g of x. What rule do I need to take the derivative of this? Chain rule. Okay, so h prime of x is going to be outside, derivative of the outside, f prime, leave the inside alone, times the derivative of the inside. So f prime of g of 1 times g prime of 1. So now I'm going to look in the table. G of 1 is 2, and g prime of 1 is 6. So f prime of 2 times 6. Okay, f prime of 2, oh my God. F prime of 2 is 5 times 6 is 30. Okay, I'm gonna do the same thing for capital H, but the G's and the F's go in the other order. So capital H prime, I still need the chain rule. Derivative of the outside, G prime of f of x, times the derivative of the inside, f prime of x. I'm still plugging in the same number 1. So G prime of f of 1 times f prime of 1. So I'm going to go to my table and I'm going to look for f prime of 1 and I'm going to look for f of 1. So I'm going to my table and I'm looking for f of 1, 3, and f prime of 1, 4. So this is G prime of, this guy was 3 and that guy was 4. I gotta go one more time to my table and look for this guy, G prime of 3. So one more time to my table for G prime of 3, 9. 9 times 4, 36. So remember, like, I think it's important that you go slowly when you do these, right? Like, write down the ones for the X. Don't just automatically put the table values in there, because then, like, what I saw is that a lot of times you have a tendency to use the table too many times or not enough times, right? Like, if you try to write down these numbers without thinking about what they are, then you forget you need the table again, but that you've already used it and you don't need it again. So just kind of go a little bit slowly and methodically when you're doing that. Yep. How far? Yeah. I can make it bigger too. That's the end of my list, but I'm happy to take more.
22.
Yep. You good? Yeah. Anybody else? Okay, differentiate e to the negative 4x times cosine of 8x. Oh, nice. E to the negative 4x times cosine of 8x. Which rule do you need? The product rule. Yep. And you'll need the chain rule as you're doing the product rule, right? Because this is e to some stuff and this is cosine of stuff. So remember, the chain rule should always be happening. So this guy's going to be f and g. So f is going to be e to the negative 4x. G is going to be cosine 8x. I would make sure that you put some parentheses around that 8x in your cosine. Okay. Derivative of the first. Derivative of e to something is e to something times the derivative of that something, negative 4, times the second, cosine 8x, plus f, e to the negative 4x, times the derivative of g, derivative of cosine, what'd you say? Negative sine 8x, times the derivative of that something, 8. If you type it in with parentheses like that, you should get it correct. If you leave out these parentheses around the sine and cosine, it's probably going to mark it wrong. So don't do that. Like right here? Oh, around here? No, once it makes an exponent, it puts parentheses automatically around that. Like it's like inherent. Yeah, but it won't hurt to put them. Like if you put them, it's going to be okay, but you don't have to put them there. Yeah. Okay, I'm going to scroll back up to the top. If you think of another question, just shout it to me, but I want to remind these due dates. Quiz 6 and D12 is due today. Handwritten quiz 5 and grade scope is today. The midterm review is due Wednesday, so it will close Wednesday night. You won't be able to work on it. It doesn't even have a late day. So if you don't do the midterm review by Wednesday, it doesn't even have its, like, you know, sometimes you get to do homework 7 days later, whatever. Yeah, like Wednesday night, I think. Let me check. Midterm review, 11:59, yeah. And then the midterm exam has two parts. The first part is the grade scope part. I don't care which order you do them in, but the first part is the grade scope part. It has to be taken during class time. It's a 1 hour time limit.
It's still online, right?
It's still online. Yep, the whole thing is online, but it has to be taken during class time. So it will open at 12:30. You can start it then. You have 1 hour once you start it. It closes at 2, whether you started it at 1:59 or not, okay? So do your best to start it like at 12:30 or 1 at the latest. And then the Xfinity portion like, is open all day Wednesday. If you're a night owl, take it Wednesday night before you go to bed, like at 2 o'clock in the morning, Wednesday morning, or if you like to take it during the day, anytime Wednesday. But again, it has a 1 hour time limit, okay? And then no class Friday. No class, no nothing to do. Take your little tiny mini vacation. Have a great week, guys. I shall see you next Monday here for word problems. That's what's happening after the midterm. Hooray. Yeah, no, we're going uphill and then we're gonna go down, right? We have to hit the top first. We have 3 weeks to hit the top and then we're gonna go down. Okay. Oh,
I did
man.
the terrible on the first one, but then the second one. So this one is my first. It was this problem.
So I would write it as, I'm never getting to the end. There we go. Okay, I would write it as, show me again, natural log 2t to the square root t. And then this guy gets to come in front. Square root t, natural log of 2t. And now when you take the derivative, you're going to use the product rule.
Which I did.
So 1/2 t to the negative 1/2, natural log of 2t plus square root t times 1/2t times 2. Okay, and this is 1/y dy dx. So then dy dx is going to be y times all this stuff. So this guy times all that stuff.
So what, I just couldn't figure out like which one it is.
Oh, there's like some refactoring that happens here. Okay, let's do a little bit. And this guy is natural. This guy is this thing. Okay, I think what happens is that this guy cancels with that guy. Yeah, and then when I do this guy times this guy, he cancels with that guy. Because I'm going to distribute this, right? So it's going to go here and here. So when I do square root t times square root t, I get t, but then it's divided by t. So that's going to look like natural log of 2t times 1/2 natural log of 2t plus 1.
There's no natural log in the beginning, at least. Maybe.
Oh, wait, there's no natural. That's not it. That's not true. Stop. This is wrong. I have to write down y. Y is 2t to the square root t. Okay, so this is 2t to the square root t. Okay, so let me, square root t over t is 1/square root t. And then I have this 1/square root t here. So maybe this is 2t square root t over square root t times 1/2 natural log of 2t plus 1. Is that there?
Yes.
Oh, there it is. That was really hard.
Yeah.
Man. Was it on both attempts?
No,
Oh,
there
okay.
was actually another one on the other tab I didn't really understand.
Just as hard.
It,
Yeah.
it wasn't this one. It wasn't like, it wasn't anything like this. It was
Ah.
a tangent, but I guess it was the same thing, like it condensed it. So I
Right.
was like, I don't know.
They, all those, yeah, like that, that's crazy talk
Can I take a
simplifying.
picture?
Yeah, totally. I don't know if I have it all on there, but.
Just this part right here, because this, wouldn't that be square root T over T though? Why
Right,
did
and
put
when
one
you,
over-
because when you